In the previous chapter, I explained to you the structure of an atom. In this section, I'm going to be taking you through the sources of electricity. That is how electricity is generated from that little component you saw in the previous session. Now, in the previous session, the three components, especially the electrons, in a natural state is in what we refer to as a static state. It is electrically referred to as not being active. Any component you pick, the electrons will move haphazardly in such a way that they don't generate any electricity. Now, to generate electricity, you have to apply a force onto a particular component to make the electrons become excited. We need their state, and they will begin to move. In fact, what happened is that electron is knocked out of its orbit whenever a force is applied to it. There are three kinds of forces that you can apply to knock out electrons from its orbit. One of such forces is referred to as magnetic force. When you apply a magnetic force around a conductor, it knocks out electrons from its orbit and they begin to move. And such kind of principle is seen from a generator. Now, I want you to look at this diagram. In this diagram, we are having a magnetic field around a conductor. We form a circuit. Now, you can see a plate that is connected in a loop using a wire. Now, if you see that small plate, you see some arrows that is moving around the conductor. The arrow indicates magnetic field. And such field generates a force that is capable of knocking electron out of its orbit. And when this phenomenon happens, what you have is what we call electron drift. Electron drift makes electron within a conductor to begin to flow in a particular direction. As you can see in that particular diagram, I have a load. You see a small rectangle with an arrow. That is a load within this particular circuit. And the electrons, when it moves, it dissipates what is referred to as energy. It dissipates energy on that particular load. Now, you can see that magnetic field is a force that is capable of moving electrons around its particular orbit. I will still come to that later on. Now, the next force that can knock off electron from its orbit is known as chemical effect. That's chemical energy. Now, when you have, in this diagram, you are having two plates that is inserted into a chemical. One of the plates is referred to as an anode. The other one is referred to as the cathode. The anode is positively charged, while the cathode is negatively charged. Now, I form a circuit around this particular composition, and you will see in between you have a small switch and you have a battery there. Then you have a copper plate, a copper sulfate solution inside the jar. Okay, this causes a chemical effect around this particular circuit and generate a force that can make electron to move from positive direction to negative direction. Conventionally, I'm going to explain what I mean by that as I proceed. Okay, the third particular force that you can apply to a conductor that can knock off electron from its orbit is also heat. When heat, an intensive heat is applied to a conductor, it can make the conductor lose the electron in its orbit and electron begins to flow. So electricity as well is generated. Now, the next thing I'm going to be talking about is the effect of electricity. Now, in this effect, you see, those components that actually generated forces, the forces that are actually applied onto electricity can be reverse engineered, you understand, to produce such forces. In the previous section, when I explained the forces that can generate electricity, I did talk about magnetism, chemical force, and then heat energy. They can generate electricity. If you reverse this, you can also generate all these three natural phenomena. You can generate them through electricity as well. This leads me to the effect of electricity.